Thank you so much. My name is Bryan Walsh. I'm the editor of Vox's Future Perfect, and I'm so happy to be here on Medium Day to be talking to a really extraordinary scientist. Professor Avi Loeb is the Baird Professor of Science at Harvard University. He's the best-selling author of the books Extraterrestrial and Interstellar. He's a deeply decorated scientist, astrophysicist. He's written more than 8 books. He's authored hundreds of scientific papers. But more recently, he's been known for the deep interest and investigation he's undertaken on the possibility of finding evidence of extraterrestrial life in the universe here on Earth. Just this year, actually, just recently, he led an exhibition to the waters off Papua New Guinea to collect fragments of a fireball from outer space that landed there in 2014, with the idea that this may actually contain evidence of an extraterrestrial origin. And he's been writing about this expedition and a lot more on media, and I'm very happy to talk with him today. Professor Loeb, let me ask you first. I mean, at what point in your career did this possibility really occur to you? Did you decide to, I'm not sure if shift the focus is the right word, but this was a subject worthy of investigation that you thought perhaps science as a whole was not paying attention enough to a sufficient degree?
Well, thanks for having me here in the conversation. I should say that every day is a Medium day for me, because I write an essay almost every day on Medium. And regarding the search for neighbors, cosmic neighbors, it started for me when a prediction that I made turned out to be wrong. Basically, a decade before the first object was reported from interstellar space, an object that entered the solar system with the name Oumuamua, because it was discovered by a telescope in Hawaii. I wrote a paper in 2007. This object was discovered 2017. And in that paper, we simply estimated how many rocks we should expect from other stars to enter the solar system and be detectable by the telescope in Hawaii that found Oumuamua. And the prediction was 0. Not only 0, the chance is less than 1%. And in fact, somewhere between a factor of 100 to 100 million, there are too few rocks that we expect based on what we knew at the time about the solar system. Then Oumuamua was discovered simply because it passed near the Earth. It was the size of a football field. That was a great surprise to me, because it turned out my prediction was wrong. So the question is, how can we be wrong by a factor of 100 to 100 million in the abundance of rocks the size of a football field? And of course, I followed the data, and every time there was a report about this object, turned out to be weird, strange, to the point where there was a colloquium at Harvard University about Oumuamua, and when I left the room together with a colleague of mine that worked on rocks for decades, this colleague said, "Oumuamua is so weird, I wish it never existed." And now this, to me, that was explained to me by a psychologist. I wrote about it in my previous essay on Medium. It's called the cognitive dissonance, when you want to follow the data, yet it doesn't really agree with your past knowledge and you get upset about it. And that's the way that the experts react. Now, as a result of being inspired by Oumuamua, I then realized there is a catalog of NASA that includes all the meteors. These are objects much smaller than Oumuamua, roughly a meter in size typically, that collide with Earth every now and then. And then I asked my student, Amir Siraj, to go through the NASA catalog over the past decade that had 273 objects and see if any of them is moving faster than the escape speed from the solar system, meaning that it's moving too fast to be bound by gravity to the sun. And we found one from 2014, almost a decade ago. And it was based on US government satellites, not radars, the way my colleagues are. They say, oh, radars have errors in them. There was, in fact, a paper last month saying, oh, this data of the government must be wrong. But in fact, the US Space Command took time away from their day job, and they wrote a letter to NASA just a year ago saying that at the 99.999%, this meteor, based on the data that they checked again, is of an interstellar origin. And the reason I bring this up is both Oumuamua and this meteor were unlike the familiar rocks that we are aware of in the solar system. So not only it was a surprise that they actually existed, but moreover, the meteor maintain its integrity down to the lower atmosphere of the Earth, where the stress was immense on it. So it had material strength tougher than all the space rocks, 272 of them in the NASA catalog, in addition to this one. And moreover, outside the solar system, it was moving faster than 95% of the stars in the vicinity of the sun relative to the local frame of the Milky Way galaxy. So if you have an object moving very fast, it might have benefited from propulsion, artificial propulsion.
I see.
And if it's very tough, it could be like a Voyager spacecraft that our Voyager will exit the solar system in 10,000 years, but then it could collide with another planet like the Earth and appear as a meteor. And about Oumuamua, there was this excess push and non-gravitational acceleration that it's exhibited relative to the sun. I suggested that it's just the sunlight pushing it. And for that, it had to be very thin, and nature doesn't make such objects. So I suggested maybe a surface layer of a bigger object, or some space trash, that was manufactured by a technological civilization. And initially, by the way, the response was very positive from many of my colleagues. But as time went on, as I got more media exposure, then people became hostile within academia. And I should say that, to me, underlines the fact that it's all about academic jealousy. And I should say also that if the public cares about a question, to pay attention to it, that's not a negative. And, one of my colleagues was quoted on the Crimson, the Harvard Crimson.
Right.
He was saying, reporters should pay more attention to boring science. And I say, why is that? Where is that coming from? Like, why should reporters pay more attention to boring science? Anyway.
So, Oumuamua obviously is beyond our grasp, not something we can reach. This object, though, this fireball that landed, I believe, out of Papua New Guinea.
About 100 kilometers, about 60 miles. Yeah.
So you and a number of other people went on an expedition to actually find this object, and you've been analyzing. Can you just talk about that expedition, what you were looking for, what it was like to be out there in the field? Because this is a pretty remarkable thing to be doing, I suppose.
Oh, yeah, it was a big challenge. I mean, so as soon as the US Space Command confirmed the interstellar origin of this object, and I knew that it has unusual properties, I organized an expedition and basically said that we must go there. The cost was $1.5 million. A few months after I wrote on Medium about the intention to go there, I had a Zoom call with Chris Hoskinson, and he said, you have the money. And then we organized a team of the best people in the world that I could have imagined, or I would have wished to have on the ship. And we hired a ship that is called, very fittingly, Silver Star. And we went there. Now, the coordinates of the US government specified the location to within 10 kilometers. That's about 7 miles or so. So that region was pretty big. And the ocean depth is 2 kilometers, more than a mile deep. And we were looking for tiny droplets that melted off the surface of the object when it was exposed to the immense heat from the fireball. The fireball, as a result of the friction of the object with air, released a few percent of the Hiroshima atomic bomb energy. So if you watch Oppenheimer, the movie, you can appreciate how big that explosion was. And it released it into about 500 kilograms. So obviously the surface of the object melted. And there were these droplets that rained down on the ocean and settled on the ocean floor, more than a mile deep. These droplets were estimated in a paper I wrote with my students to be less than a millimeter, the head of a pin, basically the size of a dust grain or a grain of sand. So think about it, searching for grains of sand, size particles across 7 miles region at a depth of more than a mile. That sounds like an impossible mission. What we did is design a sled that had magnets on both sides, and we dragged it on the ocean floor, just like mowing the lawn. The sled was 1 meter in width, and we went back and forth across a region of 7 miles. And amazingly, we collected some magnetic particles. We had a plan B. If there was no magnetic residue from this meteor, then we would have gone after non-magnetic particles. We had a sleuthing device, but we didn't need to use it because we started collecting stuff. And the most obvious stuff was black powder, basically volcanic ash.
Right.
And on the 6th day, so I wrote 43 diary reports. And on the 6th day, my diary report, you can find it on Medium, was titled, "Where are the spherules?" Now, this illustrates two things. One, I'm willing to admit when I'm not successful. I'm saying that, where are the spherules? We were looking for those molten droplets. We didn't find them. I wrote an essay saying we didn't find them. So to all these, naysayers who say, "Oh, he, exaggerate." I'm not exaggerating. I'm telling you the truth, straightforward. So we didn't find them, and I was wondering if they are there. And then a day later, we started filtering the black powder, the tiny particles of volcanic ash, out of the sample by using a mesh with a mesh size of about 1/4 of a millimeter. So the bigger particles stayed. And then we put them under a microscope. And I remember the geologist on the team running down the stairs. That was Jeff Wynn, telling me, I was the chief scientist on this mission. So he came to me and said, "Avi, we found a spheral." And I said, "Wow, that's amazing." I ran up and I hugged the person who found it first, Ryan Wood, on the microscope image. And I said, "You can't believe how amazing this is, because, we invested so much time and effort. And now we found it." And I knew from finding, an ant in the kitchen. I wash the dishes every day, and I know when I see an ant, there must be many more out there. And sure enough, we found many more spherules. And then, and there were 50 of them. I put a whiteboard where we marked all the 50 of them. It's just behind me over there. And then when I brought the sample back to Harvard, I had a summer intern, Sophie Bergstrom, who was interested in actually science journalism, but said that she's happy. She wanted to shadow me in my scientific work, but she said, if I can be helpful in doing the science, I'll be glad to help. So I arranged for her tweezers and a microscope. And amazingly, she found 650 new spherules. And I should say that's a factor of 10 more than on the chip. So by now we have more than 700. And we are going through the sample of spherules. I cannot give you the details. We already have some results, because all of these details will be described in a scientific paper that we hope to put out within a month. But I can tell you that it's exciting what we're finding.
Without talking about the details, obviously, because I don't want to preempt the paper, what are you looking for, I suppose? I assume here the theory is this is not a natural object. This is a alien made, I suppose. How would you know that, or what would the evidence be that you might see that would sort of support that theory, I suppose? Right.
So this meteor was moving very fast based on its speed, as measured by the U.S. government satellites. We could infer that it came from outside the solar system. But here we have another opportunity to do so, because the spherules were concentrated along the meteor path. So there was a background of spherules. Of course, everywhere on Earth you have some spherules, but there was twice as many along the meteor path, meaning that the meteor added some spherules to any background that was there. And that provided a smoking gun that we are in the right place. Why would it be exactly along the expected meteor path, which we, by the way, narrowed down using a seismometer that was on Manus Island, Papua New Guinea, that measured the distance to the explosion from the delay in the arrival time of the sound wave. So we were able to pinpoint the meteor path, and indeed we found more spherules there. But the first question is the material composition of those spherules very different from solar system materials? You see, the entire solar system formed out of a gas cloud that was enriched by an exploding star nearby, a supernova. And so it was mixed, and the solar system has nearly the same abundances of elements everywhere, except of course, some elements evaporate, and we know how to account for that. And so, so given the fact that we know the solar system composition, we can ask: are the spherules representing a different set of element abundances? And that is straightforward to figure out using mass spectrometers. Now, if we demonstrate this to be the case, it would constitute an independent confirmation that this object came from outside the solar system, unrelated to the speed, which many of my colleagues disputed. They said, "You don't believe this, the US government." And I say, well, I wouldn't sleep at night if I were you, because you're saying that the US Space Command, which gets more funding than NASA, which is supposed to tell President Biden whether a ballistic missile is heading to the US, makes a mistake by a factor of 3 in measuring the speed of an object. I mean, that would mean that they would alert the president.
It's a scary thought, yeah.
I mean, they would alert Mexico for a ballistic missile instead of Biden. So my point is, we can sleep better at night because we found it there, despite what my colleagues are saying. And moreover, we are analyzing their composition, which will give us an independent test of whether the US Space Command is doing its job, whether we are paying taxes for a good reason. Because otherwise, you would be really worried that they don't know what they're talking about. Okay, which is a claim that was published in the Astrophysical Journal by my colleagues a month ago. Just to put it on the table, it was a claim in the Astrophysical Journal of a refereed paper, meaning it's not just the authors, it's the people who reviewed their paper who agreed that the US Space Command can be wrong by a factor of 3 in measuring the speed, so that this object would fit a stone that we are used to in material strength, and would move at a speed that is 3 times slower, so it would belong to the solar system and not from outside. And I call that the Stone Age of science, where everything in the sky has to be stones. You fit a model, and if it doesn't match a stone, you say the data is wrong. That's not the way I was educated as a scientist. If your model doesn't fit the data, you should think twice about whether the model needs to be revised. No, these astronomers say, no, the data must be wrong, and it must be a stone. And I held in my hands those spherules that I knew from the ship already, from the X-ray fluorescence analyzer on the ship, that they're made mostly of iron. So clearly this paper is wrong, appearing exactly when I came back in my hands. I had the materials. So I'm asking, I'm a theoretical astrophysicist. The reason I decided to embark on an experimental project was so that, I will have the proof, the evidence. And even when I bring it back, still, you get people denying it. Now, the other thing I should say, that before I went there, I had colleagues saying, why waste this time, money, effort? Why are you doing that? And they said, you will not find anything. And I said, well, I'm not asking you to do anything. You just sit back, relax. I'm not taking money out of your dark matter research. I'm just doing all the heavy lifting with a team of 28 people. We're going there. It's a lot of effort. And, we went there and we found something. That's the amazing thing. And now they say you didn't find anything. But I know that I found something. And it will all be detailed in the paper, the scientific paper. Now, why is this important? Because it's a teaching moment. It's a teaching moment about the response of what is supposed to be blue sky science to evidence. Science is supposed to be guided by evidence, by data. And you should have the most respect to data as a scientist, because often new knowledge stems from new data. However, if you keep arguing the data must be wrong, and not only that, it's the data collected by US satellites that the US Space Command is using to monitor ballistic missiles, you are making a statement that the government doesn't know what they're talking about by a factor of 3. You are willing to do that and deny and argue that this object must be a stone, and then I go there and see that it's not a stone, and you are still ridiculing that expedition. That to me is a violation of the definition of a scientist.
I just want to take a moment to remind the audience they can send questions in via the comment function. And Professor Loeb, behind you, actually, you can see a sign for the Galileo project. And that obviously made me think what you were just talking. I mean, Galileo, a scientist who challenged the orthodoxies of his time, to say the least, and also paid for it in doing it. I mean, do you see yourself doing something similar? Or do you feel that there's an orthodoxy around this subject that you are directly pushing against? I mean, I have to imagine the name of that isn't incidental.
Well, I'm not trying to reproduce anything from the past. I always look forward. And, when I went on the jet, it was a private jet. The pilot said to Papua New Guinea, the pilot said, "Welcome aboard, Professor Loeb." And I said, "Forget about titles. You can call me Avi, because fundamentally, I'm a curious farm boy. I was born on a farm, very much connected to nature. I don't pretend to be anything beyond that. And I'm very curious. I maintain my childhood curiosity. And that defines me, basically. And, I feel that we have to follow evidence to review whether our prejudice is correct or not. We should be open-minded. That's what academia is supposed to be. That's why there is a tenure in academia, so that you can pursue the truth without worrying about your job security. And yet, what you find on social media is an undertone of negativity. What you find very often is people responding to innovative ideas with ridicule, bullying, and it all stems from academic jealousy, the fact that it gets attention in the public. Now, I say, don't blame me for the attention. That has to reflect the interest that the public has. Now, of course, there are clickbait distortions of what I say. If you listen to video conversations that I have, that's exactly what I say. Anything deviating from that has to do with reporters distorting my message, and it's not what I say. So don't pay attention to titles of articles that are saying something different than you heard just now.
Let me ask you, in the past, I think our chief means of searching for extraterrestrial life was through radio signals. We were looking to see if someone was calling us, essentially. You're looking for something different. You're looking for, I guess, we call them techno-signatures, perhaps, evidence of alien technology, not evidence of an actual life form visiting us, but perhaps a tool they use. Talk about that theory. I mean, just tell me more.
That's an excellent point. In fact, over the past 70 years, and this was really pioneered by Frank Drake, who passed away last year. The idea was that, after we invented radio communication, the idea was that perhaps we can listen to radio transmissions from other planets far away. And it was a reasonable idea. The only thing to keep in mind is our science and technology is only a century old. And of course, we will imagine what we are producing, but what we are producing now is very different than what we did a century ago. And obviously, a civilization far more advanced than us may not actually communicate with radio waves. But at any event, that was the method adopted. And it's similar to waiting for a phone call. You need someone to be active to transmit a signal so that it will arrive to you when you are listening. That has not been successful. We've tried it for 70 years. There is the whole SETI community doing that. My suggestion is to try a different method, which is to go out and check your mailbox or check your backyard. Maybe there are packages that were sent by someone a long time ago. And the advantage of this method, well, first of all, we sent out 5 probes, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons, to interstellar space over the past half a century. And you can just imagine others doing that for a very long time. And you would find all these rockets in interstellar space that are not functional anymore. They're just like space trash, similar to plastics in the ocean. They keep accumulating over time, the plastics. And the same is true about interstellar space, because these objects are moving at a speed that is less than 1/10 of the speed necessary to escape from the gravity of the Milky Way galaxy. So in fact, these objects are bound to the Milky Way, and they will keep accumulating. Whereas radio signals, move at the speed of light. After 1 billion years, they will be 1 billion light years away. If you didn't listen, you just missed the opportunity. So it's a very different approach. And the wake-up call came in the form of these 2 interstellar objects that were only discovered over the past decade. So we now have instruments that we didn't have before the last decade. So I'm saying okay, now let's try this completely new method. And what I hear back is the SETI people saying, oh no, that's not really SETI. They have a problem with it. I'm not sure why. I mean, it's an alternative and it makes a lot of sense to me. But one thing I recognize is common sense is not common.
Interesting. You mentioned Frank Drake, of course, creator of the Drake formula, Drake equation, sort of the idea to try to estimate the probability of life outside our solar system. Thinking back to that time period when he was active, I mean, there were scientists like Carl Sagan, there was SETI, there was actual government funding for this work. That all went away. And now, as you know, based off the response, most mainstream scientists seem to dismiss this. What changed, I suppose? I mean, what from that era, from the era of Drake and of Sagan to now, such that you're being received the way you are, I suppose?
Well, first of all, we know now that stars like the sun have planets the size of the Earth, roughly the same separation. And the fraction is still debated. It's between a few percent and a few tenths of percent. But it's a substantial fraction. So there are billions of Earth-Sun systems out there. And by the way, we have only 1 billion years left. It's 20% of the age of the Earth before the sun will boil off all the oceans. So just think about the fact that most sun-like stars formed billions of years before the sun. We know that from the cosmic history of star formation. So that means that other planets like ours were already burned up. Okay, and there must have been a huge exodus of civilizations from those planets. There were tragedies throughout the cosmic history of those civilizations crying for help. It was the biggest item in their news, and we were not around to listen to it. Humans just came to exist, the human species, only over the past few million years. And that's 1 part in 10,000 of the age of the universe. And I always say, if you come to a play and you are not at the center of stage, we know that we are not, and you are also not arriving at the end of the play is not about you. And it's better to find other actors who were around for a longer time to figure out what the play is about.
Interesting. We have a number of questions from the audience asking about the recent congressional hearings that involved David Grush, among other people. Again, simultaneously, we have the attitude of mainstream science on one hand, but you obviously tremendous public interest, now increasingly a lot of interest from aspects of the government. So, yeah, tell me, as this question, I mean, what do you think of it, and how do you think the justification narrative that's being put out here, whether it's nation-state defense concerns or an ontological shock of what that would mean for alien life? Just your opinion on this.
Yeah. So first, I should say that it's not obvious to me that we can figure out what lies in interstellar space beyond the solar system, first from the bottom of the Pacific Ocean or from politicians in Washington, D.C. I mean, I'm doing my best as a scientist, and I will not wait forever for the government to do the right thing, because the sky is not classified, the oceans are not classified. We can go ahead and explore them. Now, what I thought about the hearing, first of all, this subject is now endorsed by both parties as important. And I guess one justification is because of national security. You want to make sure that these objects that are not identified do not belong to adversaries. But there was this report by David Grush, and the good news is that he said he spoke with 40 eyewitnesses who were part of programs for retrieval and reverse engineering of alien spacecraft that the US government has in its possession. Perhaps the US government shared with potentially with corporations. We just don't know. But he has the names of those and the contact information of those 40 individuals that he promised to deliver to Congress people. And now they can go down this rabbit hole and figure it out. That's the good news, because if we don't hear anything within a year, it may be a fabricated story. I mean, David Grush himself did not have firsthand evidence that he could share with us. But if there is something there, we might hear about it. You see, it's all about evidence. As a scientist, I should tell you that people can say whatever they want. And in fact, when people are involved in a car accident, you have very different reports from different people. So you can't really rely on what people say as scientific evidence. That's the difference, between, I mean, in science, if you want to write a paper, you have to use data from instruments that are well calibrated and under your control. And we see it already in the FIFA World Cup. If you watch the women's soccer matches, I mean, in some, especially in the case of the US being kicked out, that was a video image where they could figure out whether the ball passed the line of the goal. And of course, it had nothing to do with what the players are saying, with what the audience is saying. There was good enough data to decide to rule. It's basically fact checking using instruments. And without that, just based on eyewitnesses telling you what happened, that cannot hold water, scientifically speaking. So, of course, now we have very good instruments that we can use to pursue this question. That's what I'm doing within the Galileo project that I lead. And we have an observatory at Harvard University that is monitoring the sky 24/7 in the optical, infrared, radio, and audio. And we're trying to analyze the data with the machine learning software to figure out whether objects are, birds or balloons or drones or airplanes or something else from outside of this Earth. And that's the only path forward. And of course, if the US government has some materials in its possession from crash sites, I would like to see it, because if you give it to corporations, it's the same situation, the same relationship that you have between a psychiatrist and a patient. A psychiatrist will never solve the problem of a patient, because if they solve the problem of the patient, they will not get paid. So the same is true about corporations that are given a task by the Department of Defense. They will not solve the problem if they are getting paid for it. And it could exist for decades without them shedding any light on the nature of these materials. However, if the materials are shared with scientists like myself, we can get to the bottom of it. It will be open data. Anything coming from interstellar space should not, be hidden from the public, because it's science. I mean, if it came from thousands of light years away and it took it more time than a few million years, we didn't exist. It doesn't care about how we split the land on this rock that we call the Earth. So national security is completely irrelevant in this case, and it should be scientific knowledge shared by all humans.
What do you think, this is a follow-up to that question around the ontological shock? I mean, what would it mean to human civilization were we to actually find what would be conclusive evidence of the existence of alien life? And I assume by that I mean something along the lines of what you're looking for, some technological signature, some piece of something from another civilization far from our solar system, not an actual visitation, not a communication, but just we would know they're there. We wouldn't know much about them, probably. We would simply know that they exist. What would that mean for all of us, do you think?
Well, I think it's an opportunity for us to recalculate the way GPS systems do, recalculate our place in the universe, what we think about ourselves. It should bring us a sense of modesty, because if we're talking about some gadgets that arrive to Earth, it means that they arrive to us before we arrive to their doorstep. Okay. And when I received those spherules by FedEx at my doorstep, I realized it took a few days for FedEx delivery, but it actually could have taken billions of years for these materials to arrive to Earth. But if we do identify technological origin of anything that arrived to us after millions or billions of years, it will bring a sense of modesty. The other thing is, on the ship, I came to recognize that we are all in the same boat. All the team members were working selflessly for the success of the mission. And you can think of the Earth as a boat sailing through the ocean of space. And humanity, the human species, should recognize that we are all in the same boat. We keep fighting with each other, trying to feel superior relative to each other. We invest $2 trillion a year in military budgets. That's not a sign of intelligence. If we were to use this money for space exploration, we could send a probe towards every star in the Milky Way galaxy within this century. I did this calculation. So our priorities are, how should I say, not very intelligent. I mean, of course, they are drawn from conflicts, in history, because, we came from the animal kingdom, And
Right.
there you have zero-sum games. If you get the food, then another animal will not get the food. So it's all about zero-sum games, trying to conquer a piece of land, occupy. And the point is, science brings a completely different narrative, which is an infinite sum game. If we figure something out, all of us benefits from it. And the point is, knowing about our cosmic neighborhood, figuring out that we have neighbors, is to our advantage, because we will be able to adapt to it. I don't care if you label it as ontological shock. I mean, it really doesn't matter. It's just like going out to your backyard after you were living for a long time in an isolated family, going out to your backyard and finding a tennis ball that was thrown by a neighbor. Of course, you should share that information with your family, because they might want to close down the curtains so that they maintain their privacy. They might choose to go out to the street and speak to the neighbors. Maybe they will learn something from them. And by the way, the neighbors might reach you. They might knock on your door or affect your life in other ways. So it's always good to know the reality that you live in.
Another question from the audience here. I mean, do you, especially talking about these kind of big thoughts here, do you consider yourself spiritual in any sense? Does that inform any of the work that you're doing now?
I do think that spirituality and the frontiers of science share one thing in common, which is exploring the unknown. And there is an art to it, because you don't know what it embodies. But there is a fundamental difference between, for example, religious beliefs and science, in the sense that science should be guided by evidence that everyone can follow and agree on what it means. It's sort of like a detective story where you collect evidence and figure out what really happened. Whereas a belief system is more subjective. It's up to you to decide whether you believe in it or not. So there is a difference, but my hope is that by finding an advanced civilization, we will bridge the gap between spirituality and science, in the sense that a very advanced technological civilization is a good approximation to God, because it could create miracles. Just imagine a cave dweller coming to New York City and looking around. Everything around technological would appear as miracles. And so I think that there is this. I'm Jewish in origin, and there was this theory that perhaps the Messiah will originate from Brooklyn.
Yes.
The Lubavitchers, the Lubavitch
Yes, I do.
community suggested that perhaps the Messiah will not arrive from Brooklyn, but from an exoplanet, and it could bring humanity to a better place.
I'm curious, well, let me ask you this. This is another question for the audience. Dr. Loeb, if you conclude that these spherules that you found are of an artificial nature from beyond our solar system, what do you do next? What's the sort of follow-up research project that you do after that?
So next is to find bigger pieces of the object. Maybe something survived, because if you can easily tell the difference between a piece of rock and a technological gadget that will have screws on it, will have a label made on exoplanet Y, and will have also perhaps buttons. And in the last class at Harvard of the spring semester, I asked my students, if we find a gadget in the next expedition and it will have buttons on it, should we press a button? And half of the class said, no way, please do not press a button, it will affect all of us. And the other half of the class said, please do, because we are very curious to see what would happen. And then one of the students said, and what would you actually do, Professor Loeb? And I said, I will take it to a laboratory and examine it before engaging with it. So don't worry.
Okay, well, I'm a little worried now at that point, but another thing that's happened this year, of course, you've written a little bit about this on Medium, is astounding advances really in artificial intelligence. And I do wonder, there's no guarantee that if these civilizations exist, that they are biological still. We have concerns about AI perhaps overtaking us, replacing us. one could imagine seeing that elsewhere. I'm just curious if you have thoughts on that
Yeah.
possibility and how that might influence what we see as well.
Yeah, so think about the most advanced technology we launched to space, which is the
Mhm.
Perseverance rover and the Ingenuity helicopter that we sent to Mars.
Mhm.
These are operated by engineers in the Jet Propulsion Lab of NASA.
Mhm.
They are controlled by engineers. And I call that helicopter parenting.
Right.
I mean, literally speaking, because they are parenting also the helicopter. And the reason that is a primitive approach is because, in the future, we'll have AI systems that are capable of, deciding autonomously what to do and based on the data that they have. And you can equip a spacecraft with a brain, artificial brain, artificial intelligence, and that would be a much better passenger to put on a spacecraft than a human, because you can make it resilient to cosmic rays. It could survive for a long time. It wouldn't get
Right.
bored on a long trip that takes millions or billions of years, and it can revive itself when it gets to the destination. So to me, the idea of AI astronauts is very appealing, and especially because across the Milky Way galaxy, it takes even light thousands of years to bridge the distance. And that means that a probe cannot wait for guidance from the senders. It has to be autonomous if it's functional, and it could be sent with some guidelines of what to accomplish. But then, it's just like dandelion seeds. When a dandelion flower sends the seeds, it has no umbilical cord connecting it to the seeds. And moreover, it doesn't provide any instructions to the seeds as to what to do when the wind carries them off. I mean, the seeds know what to do. They distribute the DNA, the genetic information about the dandelion, so you will have more flowers elsewhere. But there is no instructions being transmitted. And so the way we operate with helicopter parenting, perseverance on the surface of Mars is rather primitive compared to nature. I'm not talking technological, even compared to what nature is doing. We haven't yet been able to do that. And I should say we are very slow, because just, the Wright brothers a century ago were able to imitate birds that humans saw for thousands of years. We don't have a car that can repair itself, the way the human body does when you get a scratch, somehow, the bleeding stops and then it heals. And I wish my car, when if it has an accident, would heal itself, but we don't have that technology. We don't have self-replicating machines the way biology, does very routinely. So we have a lot to learn. That's my point. Once again, we should be humble, modest. That's the fundamental. We are students of nature, and that's why I said that. I as a farm boy, I really appreciate nature. I jog every morning at sunrise. I really enjoy the company of birds, bunnies, ducks, because there is a lot for us to learn from nature, and we keep, bragging about our accomplishments. And the wake-up call will come when we notice that there is a smarter kid in our class of intelligent civilizations, because then we might aspire to imitate that kid. And my daughters, when they were born and young and at home, and they thought the world centers on them, and of course they had a psychological shock when I took them to the kindergarten and they noticed a smarter kid. That was a shock, but it was good for them, because then they learned to be better.
Just one last question, very briefly, because I think we have about 1 minute left. Do you think human beings can or ever will leave the solar system? I mean, ourselves, biologically, versus sending out probes we're already doing?
Well, if we were to use the current spacecraft, it would take us about tens of thousands of years, like at least 10,000 years to leave the solar system. And to reach the nearest star, about 50,000 years. That's the time that elapsed since the first humans left Africa.
Right.
And, if we were to send a spacecraft of the type that we're sending now, back then, when humans left Africa, it would reach the nearest star just now. So it's really a long journey. You have to go through many generations, given the biology that we now have. So either you make a superhuman, something that is capable of living for, tens of thousands of years rather than 100 years at most, or you send AI astronauts, which I describe, by the way, in my new book coming out in a couple of weeks.
Excellent. Well, I think that's a perfect place to end. Professor Loeb, thank you so much for the conversation. Very much looking forward to the publication of this paper and your book. And you can obviously follow Dr. Loeb on Medium. Thank you again.
Thanks for having me.